In this video, we're going to look at function notation, and that's just a different way to write equations. So if we have an equation such as y equals 3x plus 2, there are times where it may be written in function notation as f of x. So this f parentheses x, we say the words f of x equals 3x plus 2. So notice both equations have equals 3x plus 2, and they're the same equation. So what's that mean for us? It means that the variable y can be replaced with this notation f of x, and that's something for us that's pretty important for us to recognize. So let's go ahead and get used to that now, that the variable y can be interchanged with the notation f of x. And it doesn't just have to be f, it's just f is the name that we chose for this particular function. And you might ask why we give a function a name, and there are different answers to that. Sometimes we just have so many different functions, different equations that we're working with, that we give them names to keep track of them all. It gets too confusing when you call 4 different equations y equals, y equals, y equals. We just need some organization. Other times, these functions, the name kind of makes sense, where f might stand for the cost of Funyuns, but also sometimes when we use this notation, sorry, that was a bad example, Funyuns, but couldn't think of anything that started with f, but sometimes it keeps track of the order. So f of x and g of x, f would be your first equation because f comes before g, so g is your second equation. But regardless, whether we use f or g or h or z, this notation can always be replaced with the letter y. Okay. Now, as far as using function notation, we got to pay attention to what letter's there. So if we want to evaluate, in other words, if we want to plug in x, we got to pay attention where we're putting it. This example down here says find g of 3, which means we're going to use equation g, which is here. And notice there's normally an x in these parentheses, but we've replaced x with 3. And what that means is anywhere that you have an x in the equation, you will substitute a 3. So go find equation g. What we're going to do is essentially we're going to put a 3 in for every x. So we'll replace this x with a 3, replace this x with a 3, and then we'll follow order of operations to determine the value when x is 3. So when we go to evaluate, it's good to use the notation g of 3 because that tells us what equation you're using and what x value you're going to plug in. So when we look at the equation, we see it starts with a -2, and then we have an x. So we're going to replace that x with a 3. And that x was squared, so we have 3 squared. Okay, continue the equation. We have a -2, and there's an x after that too. So we're going to replace that x with a 3 as well. And the equation ends with a +5, and we're ready to evaluate. So I'm using parentheses to remind me to multiply here. I'm using parentheses to remind me to evaluate the exponent before I try to multiply here. So use parentheses when you substitute. And so as we start evaluating, order of operations says we should go to exponents before we try to multiply. So 3 squared is going to be 9. And so we have -2 times 9 now, and there are no other exponents, so everything else will stay the same. All right, and now order of operations says we should multiply. So we have 2 cases where we need to multiply. Watch your signs. This is a -2 times 9 and a -2 times 3. And so we're going to get -18 here. -2 times 3 is -6, and we still have our +5. Combine all of those. -18 minus 6 is -24, plus 5 puts us at -19. And so our final result is g of 3 equals -19. And what that tells us is that when we substitute a value of 3 into equation g, we're going to get an answer of -19. And so what does that represent? 3 is our x value that we used. -19 is the y value that goes with it. So function notation can show us our ordered pairs. 3 is paired with -19.